So in the last class, we were discussing about decision making under risk. Okay, we have already seen decision making under uncertainty. Okay, and we have seen the problems under that. So in today's class, we'll just recap what we saw in the last class, which is decision making under risk. Okay, and we saw what is course of action, what is state of nature, all that we have seen. Okay, I'll just repeat it. We'll give a recap of that. Okay, decision making under risk, we use it when we have situations wherein we know the probability that a situation can arise. Okay, for example, you are the marketing manager. Okay, you wanted to launch a product into the market. Okay, you have sometimes you might have higher demand for the product. Okay, sometimes you can have lower demand for the product. Okay, that is not in your hand. That is according to the customer's wishes and okay, their it is their demand. No, so that is not under your decision. Okay, so what is not under your decision is called as state of nature. Okay, that is also called as event or SON. That is state or nature. Okay, so that is higher demand, lower demand, or the market is becoming buoyant, or the market is becoming sluggish. Okay, all that is called as states of nature. Okay, and for the states of nature, we will have different probabilities. Okay, there is 0.6 probability of having a higher demand, or there is 0.4 probability of having a lower demand. All that is how you can explain states of nature. Okay, so decision making under risk means you know the probabilities of the states of nature. Okay, so what are states of nature? Higher demand, lower demand. Okay, things which are not under your control. Okay, which if you are a manufacturer, okay, or if you are a marketing seller, okay, things which are not under your control will be called as states of nature. Okay, and under decision making under risk, you know the probability of each of the states of nature. Okay, higher demand, the probability is 0.6, or for lower demand, the probability is 0.4. Okay, so you know the probability. Okay, so such concepts will bring it under decision making under risk. Okay, in decision making under uncertainty, what we discussed in 2 classes before, decision making under uncertainty, in that case, we did not know the probability. Okay, but in this case, decision making under risk, what is the concept is we know the probability that different situations can arise. Okay, so for that we have 3 methods under decision making under risk. Okay, first one is EMV, second one is EOL, and EVPA. Okay, we'll be discussing these 3 today. Okay, we have already discussed the same things in the last class also. Just I'm giving you a recap of it. Okay. So first one is expected monetary value. It is called as EMV. Okay, so what is the formula for that? EMV is equal to payoff into probability. We already know that if it is risk, okay, we know the probabilities. Okay, so for EMV, we are actually multiplying payoff into probability. Okay, for a specific COA. What is COA? COA means the different strategies. Okay, for example, course of action. COA means course of action. For example, you are a marketing manufacturer. You have to decide whether you have to launch strategy 1 or strategy 2 or strategy 3. Okay, these are under your decision. Okay, your control, whether to launch 1, 2 or 3. Okay, so things under your control is called as COA, that is course of action. It is also called as decision or strategy or alternatives. Okay. SON means which are not under your control. Okay, so EMV, how will you calculate EMV? Expected monetary value, you will calculate it as payoff into probability. Okay, payoff means for strategy 1, what is going to be the profit? Okay, multiplied by the probability that such a situation will arise. Okay, similarly, for strategy 2, how will you calculate EMV? You have to just multiply payoff into probability of the situation to arise. Okay, then we'll add all those values and then we'll compare which is the highest. Okay, because it is profit, whichever is the highest EMV, we will select that EMV. Okay, when we see a problem, we'll understand it better. So we'll just go to the formulas now. So decision will be for the EMV which is the highest. Okay, we'll compare the EMV value of strategy 1, 2 and 3. Okay, the highest EMV value is what we will select. Okay, that strategy is what we are going to launch in the market. Okay, Second one is expected opportunity loss. Okay, expected opportunity loss is actually a different version of EMV. Okay, for this one you will be actually considering the profit. Okay, payoff, if nothing is mentioned, I have mentioned in the previous class also, payoff, if nothing is mentioned, it is the profit matrix. Okay, profit that we are meaning by payoff. Okay, or if it is mentioned as cost payoff, then it will be the cost that is written in the matrix. Is it clear? Please write it somewhere. Okay, just payoff means it is the profit matrix, or if you are saying it as cost payoff, then it means the matrix is going to have values that is related to the cost of the product. Okay, the next one is expected opportunity loss. In opportunity loss, we have already seen how to make the opportunity loss table, right? From the payoff table, you can create the opportunity loss table. Okay, opportunity loss table is also called as the regret table. Okay, regret table. Okay, it is also called as loss table, or it is also called as opportunity loss table. Everything means the same itself. Okay, now how will you make this opportunity loss table? By taking the greatest payoff. See over here, we will have to make one payoff matrix. Okay, from this matrix, you will take the highest value in a row. Okay, highest value in a row, and then subtract each of the values by that highest payoff. Okay, so we will get the opportunity loss table. Okay, greatest payoff minus actual payoff. Okay, if you do that calculation, you will get the opportunity loss table. Don't worry, when you see a problem, you will understand it better. Okay, that is the opportunity loss table. Okay, so now how will you make the opportunity loss, expected opportunity loss? For that, we have a formula, EOL is equal to opportunity loss into probability. Okay, it is a similar formula over here. Over here, it is payoff into probability. In this, it is opportunity loss into probability. Okay, over here, this is going to be the least EOL that we are going to select. Okay, because in the first one, it was related to profit. Okay, profit, we always wanted to maximize the profit. Okay, but in this case, it is the loss. Okay, so we always wanted to minimize the loss. Okay, so we have to take a decision wherein the loss is minimum. Okay, next one, the third one under the risk category is, third formula is expected value of perfect information, which is also called as EVPI. Okay, EVPI, you have to be careful over here. Expected value of perfect information. See over here, we are mentioning it as off. Okay, and what is that? EVPI. Okay. Okay, so EVPI is equal to expected value with perfect information minus maximum EMV. EMV we already know, right? The first formula we have studied EMV. Okay, that maximum EMV is what we are selecting over here. That value is getting subtracted from expected value with perfect information. Is it clear? Over here, the formula contains, the main formula is expected value of perfect information. Okay, that is EVPI. In that formula, you have expected value with perfect information. Okay, minus maximum EMV. Okay, I will explain about this when we see a problem. Okay, then only it will be more clear for you. So I'll show you a small problem there, and then we'll go into the problem that we discussed on in the last class. Okay. So this is a problem for understanding EMV, that is expected monetary value. Okay, EMV is expected monetary value. Over here, you are given a payoff table. Okay, so if nothing is mentioned, payoff means profit. Okay, so over here, what happens is we have the first column there. Over there, we have SON, that is state of nature. Okay, I told you already, know that is the higher demand or the lower demand, or the market is bullish or the market is sluggish. All those is states of nature. States of nature is, in other words, which you don't have control as a marketer, okay, or as a marketing manager. You don't have control over how the market is going to be, no? So such factors you will write it under SON. Okay. Then we have COA. COA means course of action. It is also called as decisions. Okay, or strategies. Okay. In that we have A1 and A2. If, for example, you wanted to launch soap 1 and soap 2. Okay, or you have the toothpaste. No? Type 1 toothpaste is A1. Type 2 toothpaste is A2. Okay. So your decisions will be taken as COA. Okay. So whenever you make a table, make sure that SON is on the first column and COA is written row wise. Okay, is it clear? Always make sure that this is done. Okay, when sometimes in the question, they will give it the opposite. They will give SON in the row wise and they will give COA as the first column. So whenever you get that, please arrange it. Just do the transpose of it and then you will get this table. Okay, so make sure first of all when you get any question, make sure that the table is in this order itself. Otherwise, you might make mistakes for the formula. Okay, so over here, what is the meaning of this table? We have two types of products, A1 and A2, or two strategies, A1 and A2. Okay, when the S1 state of nature is S1, we have a payoff of 30. Okay, and when the state of nature is S2, in A1 we have a payoff of 35. Okay, what is the meaning of this? Sometimes over here you have two strategies. Okay, the market is having a very less demand. Okay, but the market is having less demand. If you launch the product A1, you will get only 30 as the profit. Okay, similarly, when the market is having higher demand, okay, customers are having very high demand. Okay, in that situation, if you launch product A1, then you will get 35 as the profit. Okay, similarly, A2 product, if you launch A2 product, when the market is having a lower demand, you are getting a payoff of 20. Okay, when the market is having a higher demand, if you launch A2, okay, you will get a higher payoff, that is 30. Okay, so that is the meaning of this payoff table. Okay, now what have they mentioned in the question? Let the probabilities for SON, S1 and S2 be respectively 0.6 and 0.4. Okay, decision making under risk, you will know the probabilities of these states of nature. Okay, so what are they telling? For S1, the probability is 0.6. S1 means, in this case, we took it as lesser demand. For the market to have lesser demand, they are telling the probability is going to be 0.6. Okay, similarly, for the market to have higher demand, the probability is going to be 0.4. Okay, now what is the question? Calculate EMV. Okay, we already know the formula. Formula EMV is equal to payoff into probability. We have seen, right? So how will you make it? The same table I have drawn over here. This is the same table. Okay, the same table I have just drawn it over here. And what they are telling? They are telling 0.6 and 0.4 are the probabilities. Okay, for S1, the probability is 0.6. So for S1, I'm making one more column here. Okay, that is probability. I'm denoting it as P bracket E. Okay, for S1, the probability is 0.6. And for S2, the probability is 0.4. Okay, what is our intention? Our intention is to calculate the EMV or expected monetary value. Same thing. Okay, this is expected monetary value. How will you calculate it? Probability into the course of action, payoff, that is written on this matrix. Okay, so how will you do that? Here 30, okay, multiplied by 0.6. This is the probability, you will get 18. Okay, similarly, 20 into 0.6, you will get 12. Okay, similarly over here, 35 into 0.4. For S2, you have to use probability 0.4. Okay, so 35 into 0.4, you get 14, and 30 into 0.4, you get 12. Okay, so we have got the expected monetary value matrix. And then what you have to do? We have to calculate, we have to check which strategy is better, right? We have to check whether A1 is better or A2 is better. Okay, for that, take this column, add the values. Okay, when there is lower demand, the probability, okay, or sorry, the expected monetary value is going to be 18. And when there is higher demand, the monetary value is going to be 14. Okay, that values we have to add it and you will get 32. And the other one for strategy A2, it is 12 plus 12, that is 24. Okay, compare these two EMV values, which is the highest? 32. Okay, why are we taking the highest value? Because we are comparing the profit. Okay, simply if you mention the payoff, it means it is the profit. Okay, so 32 is the highest value. So our optimal decision will have A1 as the A1, and A32 corresponds to A1, right? So A1 will be the better strategy as compared to A2. Okay, is this clear for everyone? This is how you calculate EMV. This is clear? Okay. See the if you don't take the probability values, okay, we have 30 plus 35 and 20 plus 30. Okay, for A2 it will be 20 plus 30. For A1 it will be 30 plus 35. Okay, but we have to take the probability values. Okay, we don't know how much, what is the condition in the market. Okay, we have to check the condition in the market. Then only then these values will have any meaning. Correct, right? Sometimes see the strategy one or the toothpaste that you're going to launch, okay, that is very good. Okay, according to you the product is very good, but if the market or the customers doesn't want the product, then is there any meaning in launching it? No. Okay, so for understanding that scenario, that is why we are calculating this multiplied value with the probabilities. Okay, only then we will understand how much the customers want, and if we launch this product, will the customers buy the product? Okay, is it clear? EMV, is it clear for everyone? Is it clear? Can you please tell me, is it clear? EMV? Buddy, EMV clear or not? Okay, so this is the problem that we saw in the last class. I'll just go through it. I'm not working out the problem now. It is already worked out. Okay, so I'll just discuss it so that you can remember it. Okay. So this is actually asked for so many university questions. Okay, if you take 5 university previous year question papers, at least 3 questions, question papers will have this question. Okay, so it is important. If you understand this logic, you will be able to solve all the questions that come under this umbrella. Okay, so just read the question. A grocery store with a bakery department is faced with the problem of how many cakes to buy in order to meet the day's demand. Okay, so there is a bakery. Okay, they don't know how many cakes to buy for each day. Okay. The grocer prefers not to sell old goods. Okay, so if you buy 10 cakes but only 5 are sold, then the other 5 will become a waste. Okay, so you have to be very careful when you are taking the decision of how many cakes you have to buy. Okay, as a grocer. Grocer means the shopkeeper. Okay. If a customer desires a cake and all of them are sold, the sales will be lost. Okay, for example, you have 10 cakes. Okay, 10 cakes, all of that is sold. All of that is sold. Okay, customers have come and then they have taken all these 10 cakes. Okay, but the 11th customer comes, he don't have a cake to buy. Okay, in that case, what will happen? The shopkeeper will face a loss. You know that, right? Next one. The grocer has therefore collected information on past sales for a selected 100-day period as shown in the table. Okay, so in the table, what is mentioned there? Okay, number of days is there and sales per day is there. Okay, for 10 days, what has happened? 25 cakes were sold. Okay, we are taking a period of 100 days. In this 100 days, the shopkeeper is taking the previous data so he can manipulate on that data. Okay, in this 100 days, for 10 days, how many cakes were sold? 25 cakes were sold. Okay, 25 customers came and then they took cakes. Okay, so 25 cakes were sold. Okay, in this 100 days, for 30 days, how many cakes were sold? 26 cakes were sold. Similarly, for 50 days, 27 cakes were sold, and for 10 days, 28 cakes were sold. Okay. What is the question? Construct the payoff table and the opportunity loss. It is also called as regret table. What is the optimal number of cakes to be bought each day? Okay. So using this table, the shopkeeper can identify on an average how much cakes he should buy. Okay, so that he can minimize the loss and maximize the profit. Okay, whether he has to stock in his shop 25 cakes or 26 or 27 or 28 cakes, he has to make a decision. Okay, based on this data. Okay, now what have they told? Calculate EMV, EOL and EVPI. Okay, we have already seen the formula. Use a cake cost rupees 0.8 and sells for rupees 1. Okay, the shopkeeper can buy the cake for 0.8 rupees. Okay, this is the cost price. Okay, the shopkeeper is buying one cake for 0.8 rupees 0.8 and he is selling it for rupee 1. Okay, which is the selling price. Okay, is it clear? So For calculating EMV, what do we need? We need the payoff. What is the formula? Payoff multiplied by the probability. Okay, so how will you get the probability? Only this much data is given. Okay, so how will you calculate the probability? Can anybody tell me? From this table, how can you calculate the probability? How will you calculate it? EMV is equal to payoff into probability. Okay, probability, how will you calculate the probability? You already know it is 100 days. Okay, in that 10 days. Okay, so what is the corresponding probability? 10 divided by 100. Okay, 10 divided by 100 is the probability there. Next one, for the second value, what is the probability corresponding to the second row? That is 30. Okay, for 30 days out of 100 days. That means the probability is going to be 30 divided by 100. Okay, similarly, here we are talking about 50 days. So what is the probability that 27 cakes are sold? It is 50 divided by 100. Okay, similarly for the last one, it is 28 cakes are sold for 10 days. So that is 10 divided by 100. Okay, if you calculate 10 plus 30 plus 50 plus 10, you will get 100. Okay, so this is how we will calculate the probability. So in question, sometimes they will give only like this. Sometimes they will give these values directly. Okay, these are the probabilities like that they will mention, or sometimes they will give it in this format. Okay, total number of days for which the data is manipulated will be given to you, and for each row, how many days are considered, that also will be given to you. So this is how you will calculate the probability. Okay, so next we'll go to the problem. So we have to draw a table, right? We have already told we have to draw a table wherein the first column is SON and the row wise we'll have COA. Okay, course of action. We need to decide what is going to be SON and what is going to be COA. Okay, SON means that is the customer's needs and demands. Okay, the customer, what is their decision? Okay, this is not under our control. Okay, so what will be the customer's demands here? The customer is going to come for how many cakes here? 25 cakes or 26 cakes or 27 cakes or 28 cakes. This is not under the control of the seller. Okay, the manufacturer does not have any control over the customer demands. Okay, so SON is going to be 25, 26, 27 and 28. Okay, we told about higher demand, lower demand, all that, no? So in this case, the customer's demands are 25, 26, 27 and 28. Okay, so in our payoff matrix, here we'll be writing, we'll have 4 columns here, 25, 26, 27 and 28. Okay, now what is going to be COA? COAs are strategies. Okay, as a manufacturer, what decision we are going to take? Okay, that is going to be COA, that is course of action. Okay, in this case, what will be the course of action for the shopkeeper? Same case, no? The shopkeeper has to decide whether he has to buy 25 cakes or 26 cakes or 27 or 28 cakes. Okay, so in all this type of questions, SOA and COA and SON is going to be the same. Okay, so here also we have 4 columns, whether the shopkeeper has to buy 26 cakes or 27 cakes or 28 cakes. 25, 26, 27 and 28 cakes. Okay, so in all these types of questions, SON will also be the same, COA is also going to be the same. Okay, is it clear till now? Okay, so just read it. Since the grocer can decide to buy any number of cakes ranging from 25 to 28. Okay, so in such situation, what will be take? COA will be the number of cakes the grocer buys. Okay, and that we are representing it as S1, S2 and S3 and S4 because he is going to stock it, no? So stock it, that first letter I'm going to take as S1, S2, S3 and S4. Is it clear? Okay, S1 represents 25 cakes, S2 represents 26 cake, S3 27 and S4 28. Okay, so that part is over. COA part is over. Next we are going to discuss about SON part. Okay, SON, this is actually the customer's demands. Okay, SON, otherwise it is called as states of nature. This is actually the customer's demands. Okay, so customer demand, customer also can demand as he likes. Okay, sometimes they can demand for 26 cakes, 25 cakes or 27, 28, or whatever it is. Okay, so over here, since the customers can buy any number of cakes from 25 to 28, okay, SON, okay, states of nature, okay, or it is also called as event, or it is also called as demand, will be the number of cakes bought by the customer in a day. Okay, let it be represented as, since it is representing demand. Okay, the first letter there I will be using D1, D2, D3, and D4. Okay, which corresponds to 25, 26, 27, 28 cakes. Okay, so clear till now? So we have already decided upon. If you solve like this 2 or 3 problems, you will be able to judge it better. Okay, so in all these cases, SON and COA will be actually the same. Okay, 25, the number will be the same. Okay, now we have to see a formula there. Okay, we have to make the conditional matrix. This is our matrix, no, payoff matrix. For that, the first column is SON. The column wise we will have, the row wise we are having COA. Okay, we need to fill the values inside this, no? For that, the values inside this is called as conditional payoff. Is it clear? Conditional payoff. Okay, for calculating the conditional payoff for this type of problems, we will have a formula. Okay, this is the formula. Sale quantity into selling price minus production quantity into cost price. Okay, this is the cost price. Sale quantity means how much cakes are sold that day. Okay, that is sale quantity. Okay, into selling price. Okay, for number of cakes that you're selling, you can associate selling price. Okay, minus production quantity. Production quantity means how many cakes the shopkeeper bought that day. Okay, he stocked how many cakes. That is production quantity into cost price. Okay, he is having some cost associated. No, he is actually buying from some wholesaler 26 cakes. For how many rupees? 0.8 is given in the question. Okay, so 0.8 will be the cost price, and over here he is selling it for ₹1. That will be the selling price. Okay, now how will you decide the sale quantity? Sale quantity, how will you decide? When the demand is lesser than the supply or the stock. Okay, how many cakes can you sell? When demand is lesser than the supply, how many cakes can you sell? For example, you have 26 cakes in your shop. Okay, only 20 cakes are demanded by the customer. So how many cakes will you sell? You will sell only 20 cakes. So that is demand. Okay, only the number of cakes that is demanded will be sold. Okay, now again, when demand is greater than supply, for example, you have 20 cakes in your shop. Okay, but over here, what happens? 25 cakes demand increased to 25 cakes. Okay, in that situation, how many cakes will you sell? Okay, you have only 20 cakes, but demand came for 25 cakes. In such case, how many cakes will you sell? Only the cakes which are stocked in your shop is what you can sell. Okay, so in such cases, it will be S. Okay, there is one shortcut. Whichever is smaller will be the sale quantity. Correct, right? Okay, over here, demand is lesser. So we will have demand here. Okay, in this case, which is lesser? Demand is greater than the stock. Stock is lesser here. Okay, so stock will be what you write over here. Okay, so D and this is how you will decide for the sale quantity. Is it clear now? Okay, is it clear? Okay, so that is how the formula is there. So the matrix that you create first, no, you have to use the formula of conditional payoff. Okay, this is the formula for that. Those values, when you multiply with the probability, we have to make a separate column, write the probability values, multiply each column with the probability values to make the another matrix, which is the expected monetary values matrix. Okay, add all those values column wise, you check the highest EMV. That is how we calculate the problem. മനസ്സിലായോ? EMV എങ്ങനെ കാൽക്കുലേറ്റ് ചെയ്യുന്നത് മനസ്സിലായോ? For everyone? ബേസിക് ലോജിക് ആണ്. ഈ ഒരു പ്രോബ്ലം മനസ്സിലായി കഴിഞ്ഞാൽ നമുക്ക് വേറെ ഏത് പ്രോബ്ലം ചെയ്യാൻ പറ്റും. ഓക്കെ, നമുക്ക് എന്താ തന്നേക്കുന്നത്? ഒരു 100 ഡേ പീരീഡിലേക്ക് പാസ്റ്റ് ഡേറ്റ വെച്ച് നമ്മൾ ഫ്യൂച്ചറിൽ നമ്മൾ എത്ര കേക്ക്സ് ഓരോ ദിവസവും മേടിച്ച് വെക്കണം എന്നുള്ള ഡിസിഷൻ ആണ് നമുക്ക് ഇവിടെ എടുക്കേണ്ടത്. Okay. അങ്ങനെ എടുക്കാൻ വേണ്ടിയിട്ടാണ് നമ്മൾ ഈ പ്രോബബിലിറ്റി വാല്യൂസ് വെച്ച് മൾട്ടിപ്ലൈ ചെയ്ത് നോക്കുന്നത്. ഓക്കെ, ഹയർ ഡിമാൻഡ് ലോവർ ഡിമാൻഡ് ഒക്കെ വരുമ്പോൾ എന്തായിരിക്കും സിറ്റുവേഷൻ എന്നുള്ളതാണ് ഇവിടെ നമ്മൾ നോക്കുന്നത്. ഓക്കെ, ഇതാണ് ഓരോ ദിവസത്തെയും പ്രോഫിറ്റ് ആണ് ഈ ഒരു മെട്രിക്സിനകത്ത് പ്രോബബിലിറ്റി വെച്ച് മൾട്ടിപ്ലൈ ചെയ്തിട്ടുള്ള വാല്യൂസ് ആണ് ഇവിടെ എഴുതിയിരിക്കുന്നത്. പ്രോബബിലിറ്റി വെച്ച് നമ്മൾ എന്തിനാ മൾട്ടിപ്ലൈ ചെയ്യുന്നത്? പ്രോബബിലിറ്റി വാല്യൂസ് ആക്ച്വലി ടെൽ വെദർ കസ്റ്റമേഴ്സിന് ഹയർ ഡിമാൻഡ് ആണോ ലോവർ ഡിമാൻഡ് ആണോ എന്നത് പറഞ്ഞു തരുന്നത് ഈ പ്രോബബിലിറ്റി വാല്യൂസ് ആണ്. ഓക്കെ, ആ വാല്യൂസ് വെച്ച് മൾട്ടിപ്ലൈ ചെയ്താൽ മാത്രമേ നമുക്ക് 100 ഡേയിലേക്ക് എങ്ങനെയായിരിക്കും സിറ്റുവേഷൻ എന്ന് മനസ്സിലാവുള്ളൂ. ഓക്കെ, അപ്പൊ ഈ ഷോപ്പ് കീപ്പർ എന്താ വേണ്ടത്? അങ്ങേർക്ക് ഒന്ന് തീരുമാനിക്കണം. എപ്പോഴും ഹോൾസെയിലറിന്റെ അടുത്ത് പോയിട്ട് ഡിഫറെന്റ് നമ്പർ ഓഫ് കേക്ക്സ് അങ്ങേർക്ക് പറയാൻ പറ്റില്ല. ഓക്കെ, അങ്ങേര് എപ്പോഴും ഒരു ഫിക്സഡ് നമ്പർ ഓഫ് കേക്ക്സ് വേണം എപ്പോഴും കടയിൽ മേടിച്ചു വെക്കാൻ. ഓക്കെ, അത് എത്രയാണെന്നുള്ളതാണ് നമ്മുടെ ഈ ക്വസ്റ്റ്യൻ. ഓക്കെ, ഒരു ഇപ്പൊ ഒരു വീക്കിലേക്ക് ഫോർ എക്സാമ്പിൾ മൺഡേ ട്യൂസ്ഡേ വെനസ്ഡേ തേഴ്സ്ഡേ ഫ്രൈഡേ 5 ഡേയ്സ് ഉണ്ടല്ലോ. 5 ഡേയ്സിലും അയാൾക്ക് പല നമ്പർ ഓഫ് കേക്ക്സ് ഷോപ്പിൽ മേടിച്ചു വെക്കാൻ പറ്റില്ല. എപ്പോഴും ഒരു കോൺസ്റ്റന്റ് ആയിരിക്കണം റേറ്റ്. ഓക്കെ, കോൺസ്റ്റന്റ് നമ്പർ ഓഫ് കേക്ക്സ് മാത്രമേ മേടിച്ചു വെക്കാൻ പാടുള്ളൂ. അപ്പൊ അങ്ങേർക്ക് ഡിസൈഡ് ചെയ്യണം എത്ര നമ്പർ ഓഫ് കേക്ക്സ് മേടിച്ചു വെച്ചാലാണ് എന്റെ ലോസ് എനിക്ക് മിനിമൈസ് ചെയ്യാൻ പറ്റുന്നത്, അല്ലെങ്കിൽ എനിക്ക് പ്രോഫിറ്റ് എപ്പോഴാണ് കൂട്ടാൻ പറ്റുന്നത്. ഓക്കെ, അപ്പൊ ഈ EMV വാല്യൂസ് കമ്പയർ ചെയ്യുമ്പോൾ അങ്ങേർക്ക് മനസ്സിലായി ഏറ്റവും കൂടുതൽ വാല്യൂസ് 5.1 ആണ് ദ ഹൈസ്റ്റ് വാല്യൂ ദാറ്റ് കറസ്പോണ്ട്സ് ടു 26 കേക്ക്സ്. എന്ന് വെച്ചാൽ ഈ മൺഡേ ടു ഫ്രൈഡേ അങ്ങനെ ഓരോ ദിവസവും 26 കേക്ക്സ് തന്നെ ഷോപ്പിൽ മേടിച്ചു വെക്കണം. ഓക്കെ, അപ്പൊ എന്താ സംഭവിക്കുന്നത്? അങ്ങോട്ട് പ്രോഫിറ്റ് അങ്ങനെയാണെങ്കിൽ ഏറ്റവും മാക്സിമൈസ് ചെയ്യാൻ പറ്റും. ഈവൻ ദോ ദ ഡിമാൻഡ് ഓരോ ദിവസവും പല റേറ്റിലായിരിക്കും വരുന്നത്. ഈ പല റേറ്റിൽ ഡിമാൻഡ് വന്നാലും അങ്ങേർക്ക് ഷോപ്പിനകത്ത് മേടിച്ചു വെക്കുന്നത് ഒപ്റ്റിമൽ വാല്യൂ ഓഫ് കേക്ക്സ് ദാറ്റ് ഹി ക്യാൻ സ്റ്റോക്ക് ഇൻ ഹിസ് ഷോപ്പ് ഇസ് 26 so that he can maximize his profit. Is it clear now for everyone? Is it clear or not? എക്സ്പ്ലനേഷൻ ആദ്യം പറയുമ്പോൾ ഇത്തിരി കുറെ എക്സ്പ്ലനേഷൻ പറയുന്നതേ ഉള്ളൂ. പിന്നെ സെക്കൻഡ് പ്രോബ്ലം തൊട്ട് നിങ്ങൾക്ക് തന്നെ ചെയ്യാൻ പറ്റും. ഓക്കെ, ഇസ് ക്ലിയർ? ക്ലിയർ ആണോ ഇത്? ഇസ് ഇറ്റ് ക്ലിയർ? ഓക്കെ, ഓക്കെ, ഹോപ്പ് ഇറ്റ് ഇസ് ക്ലിയർ. If it is not clear, please let me know. Okay, so that is about EMV. 26 cases is what we are deciding. Now we'll see how EOL is done. Now, our question answer, we had to find EMV, EOL, and EVPI. Okay. Okay. So next one is to find out the EOL, that is expected opportunity loss. Okay, this is another version of EMV. Here we are considering the profit, but in this we are considering the loss. Okay, the decision from EMV and EOL is going to be the same. It won't be different. Okay, sometimes you got a profit of when you bought something, you got a profit of 5. Okay, in that itself you can check how much difference or how much loss you had when you did not select some other better product. Okay, so EMV പറഞ്ഞാലും EOL പറഞ്ഞാലും your decision is going to be the same. Okay, EMV കാത്ത് we in our previous problem we got 26 cakes അല്ലേ? അപ്പൊ EOL select ചെയ്താലും നമുക്ക് 26 cakes തന്നെയായിരിക്കും നമ്മുടെ decision. Okay, so we'll see how EOL is calculated. Okay, so this is EOL. Okay, we have EOL means it is expected opportunity loss. Here we have the regret table. Regret table is equal to maximum payoff minus payoff. Okay, for that we need the payoff matrix, right? Payoff matrix, from where will we get the payoff matrix? Question number 1, we already made the payoff matrix, right? See, this is a payoff matrix. This part is called as the payoff matrix. Okay, from this you have to calculate the opportunity loss table. How will you do that? What is the formula? Take the maximum payoff minus payoff. Okay, maximum payoff from each row. Okay, regret table you will always take it as row wise, right? Do you remember that? When we talked about decision making under uncertainty, we had already mentioned that regret table calculates the values row wise. Okay, but for other type of calculations you will do it as column wise. Okay, so for making the regret table is equal to maximum payoff minus payoff. Okay, we are going to calculate this as row wise. Okay, This is going to be row wise. Okay, so in the first row, what is the maximum value? This is the payoff matrix. First row, what is the maximum value? It is 5. Okay, so regret table will have what values? 5 minus 5, which is 0. Okay, 5 minus 4.2, that is 0.8. Okay, 5 minus 3.4, that is 1.6. 5 minus 2.6, that is 2.4. Okay, so first row of the regret table is over. Next, second row, how will you calculate? Take the second row of the payoff matrix, which is the maximum value. Maximum value is 5.2. Okay, subtract all other values from the maximum value. Okay, 5.2 minus 5. What is it? It is 0.2. Okay, similarly 5.2 minus 5.2, that is 0. Okay, 5.2 minus 4.4, that is 0.8. And 5.2 minus 3.6, that is 1.6. Okay, similarly you calculate the regret table. You have the probability values multiplied with the probability values column wise. Okay, column wise, 0 into 0.1. Okay, you will have the value here. Similarly, 0.8 into 0.1, you will have the value here. Similarly, 1.6 into 0.1, you will have value here. 2.4 into 0.1, you will have value here. Similarly, calculate all this. 0.2 into 0.3, calculate the value here. 0 into 0.3, you have value here. 0.8 into 0.3 here, and 1.6 into 0.3 here. Okay, similarly calculate all this. This will be the expected opportunity loss matrix. Okay, and column wise you take the you sum all the values here, 1, 2, 3 and 4. These 4 values you add it, you will get the value here. Okay, similarly column wise you add the first 4 values, you will get the value here, and over here and here you calculate it. Since this is the EOL, okay, this is the expected opportunity loss. Okay, you have to select the least value from these 4 values. Okay, whichever is the least value, that strategy is what you have to select. Okay, I have not taken the table over here because it is time consuming now. So what I did is, you have to calculate column wise, right? So that entire value I have just taken it down here. Can you see what you have to do? We have to do it column wise. For each strategy, multiply with the probability values column wise. Okay, so 0 into 0.1. Okay, that is 0 into 0.1 plus 0.2 into 0.3, 0.2 into 0.3 plus 0.4 into 0.5, 0.4 into 0.5 and 0.6 into 0.1, 0.6 into 0.1. Okay, all these values added, it will be this column. Okay, this column here. Okay, this 0 into 0.1, it is a value here, plus 0.2 into 0.3, it will be the value here, plus 0.4 into 0.5, it is a value here, 0.6 into 0.1, it is a value here. So you will get all the values added, you will get this value. All this value added, I have got it as 0.3, 0.32. This is actually 0.32. Okay, similarly, next one, this entire column, you multiply and add it with the probability column over here. Okay, sorry, probability column over here, and you will get the value that is to come over here. Okay, I have got it as 0.22. Okay, 0.22, and over here this is 0.42, 0.42, and over here I have 1.12. 1.12. Okay, see 1.12 over here. In this, which is the least value, first one is 0.32, then you have 0.22, then you have 0.42, and then we have 1.12. Which is the least value? Least value is for 0.22. Okay, 0.22 corresponds to which strategy? S2, that is 26 cakes. Okay, so by EOL also we are understanding that we have to buy 26 cakes for optimal profit. Okay. Why did we take the minimum value? Because it is opportunity loss. Loss, no? We have to always minimize the loss. So the least value among all these 4 values will be our strategy. Okay. So over here we have least EOL is for S2. Okay, which is equal to S2. The value of EOL is for S2 is 0.22. Okay. EOL for S2 is 0.22. So decision is going to be 26. Okay. Is this clear? So that is about EOL. EOL, this matrix, we are actually forming it from the payoff matrix, which we have already received from the first question. Okay. The last question in this is to calculate the EVPI. Okay. EVPI, I will tell you what EVPI is. It is expected value of perfect information. You have to be careful with the keyword over here. Okay. In the question, it will be asked EVPI, which means expected value of perfect information. Okay. For that, what is the formula? Expected value of perfect information. What is the formula? It is equal to expected value with perfect information minus maximum EMV. Okay, max EMV. Max EMV. Okay. What is the meaning of this is? See, if you had perfect information, what is the meaning? What is the extra profit that grocer will get if he has perfect information? Perfect information, what is the meaning of perfect information? It means on a day, okay, you already know on Monday the profit is going, the demand is going to be 25 cakes. Okay, on Tuesday the demand is going to be 26 cakes. You already know the demand. Okay, you already know exactly what the demand is. Okay, that is called as perfect information. Okay, on Friday it is going to have a demand of 27 cakes. Okay, like that. If you already know the number of demands that is going to take place, okay, then what will you do as a manufacturer? What will you do on Monday? If the demand is going to be 25 cakes, what will you do? On Monday, you will create, you will manufacture exactly 25 cakes. Okay, so that you will not have any loss, or you will not have any lost customers. Okay, so if you have perfect information, then what is the extra profit that you are going to make? That is the meaning of EVPI. Is it clear? Okay, if you have perfect information, what is the extra profit that you're going to make? That is EVPI. Okay, so maximum EMV means without perfect information, what is the profit that you're going to make? That is EMV. That we have already calculated in question number 1. No, in that question number 1, we have already calculated EMV, maximum EMV. That is when you don't have any perfect information. There we took different situations, no, D1, D2, D3, D4. Okay, but the question is EVPI. EVPI means with perfect information, what is going to be your extra profit? Okay, so how will you do it? With perfect information, you are going to calculate what is going to be your profit. Subtract it with your profit when perfect information was not given to you. Okay, subtract these two values, then you will understand what is going to be your profit when, what is the difference or what extra profit you can make when perfect information is given. Okay, I'll repeat it once again. EVPI means expected value of perfect information. Okay, what is the meaning of that? We have to find out what is the extra profit, okay, that you can make when perfect information is given. Okay, perfect information means on a given day, you already know what is going to be the demand. Okay, so 25 cakes is a demand, then you will manufacture 25 cakes itself. Okay, on another day, if 27 cakes are demanded, then you will manufacture 27 cakes. Okay, in that situation, the profit is going to be EVPI. Okay, this is the maximum profit that we can attain in such a perfect information case. Okay, this is the maximum profit. Okay, when perfect information is not given, we have already calculated our profit. Okay, that is EMV. Question number 1, we calculated that. Take the difference of these two, you will understand what is the extra profit, okay, that you will get when perfect information is available. Clear? Okay, for that, EVPI is equal to EVPI minus EMV. Okay, be careful. EVPI in the first case, it is expected value of perfect information. In the second one, expected value with perfect information. Okay, so first we'll see how to calculate EVPI. Okay, expected value with perfect information. Okay, expected value with perfect information means how do you calculate? You take the highest payoff from the payoff matrix. Okay, this is our payoff matrix. Payoff matrix. In each row, you take the highest payoff. Okay, because perfect information is given, no? So on a given demand today, we will get the highest profit. Clear? Perfect information means we are going to get the highest profit. So from each row, you take the highest payoff value. Okay. First row, what is the highest payoff value? 5. Second row, what is the highest payoff? 5.2. Third day, what is the highest payoff? 5.4. And on the fourth row, the highest payoff is 5.6. Okay. Take these values. Okay. 5, 5.2, 5.4 and 5.6. Okay. It will form a diagonal like this. These are the maximum profit values. Take these values. Okay. Here I have 5, 5.2, 5.4 and 5.6. For each of these situations to arise, what is the probability? 0.1, 0.3, 0.5 and 0.1. Multiply this 5 into 0.1 plus 5 into 0.3 plus 5.4 into 0.5 plus 5.6 into 0.1. Okay, you will get the value 5.32. Okay, so this is expected value with perfect information. Okay, now what we have to do, we have to calculate expected value of perfect information. Okay, of perfect information is equal to expected value with perfect information minus highest EMV. Highest EMV we have already calculated now. This is our first question. Highest EMV was 5.1. Okay, so that's subtracted with 5.1. You will get 0.22. Okay, so what is the meaning of this? This is perfect. This is the expected value with perfect information that we are subtracting it with highest EMV, that is 5.1. You will get 0.22. Okay, what is the meaning? If you had perfect information, then you could have made an extra profit of 0.22. Okay, this is your extra profit. Okay, what profit we actually got? 5.1. Okay, without having perfect information, we got a profit of 5.1. Okay, if we had perfect information, our profit would have been 5.32. Okay, so what is the difference of it? What is the extra profit that you could have made? That is 0.22. Okay, is it clear? So that is the meaning of EVPI. Okay. Okay, we'll see one more type of problem. Okay, in the last case, what happened? In the last case, what happened? The customer, okay, buys 25 cakes. Okay, he stocks. In the last problem, okay, he stocks 25 cakes. Okay, demand is for 20 cakes. Okay, he gives 20 cakes. He sells 20 cakes because he has 25 cakes. Demand is lesser, so he can sell 20 cakes. Okay, now what about the leftover? We did not speak anything about the leftover because the shopkeeper did not want to sell old cakes, because so he had to throw away the 5 cakes. Okay, leftover 5 cakes. Okay, so about this 5, about this number, we did not talk anything in the last question. Okay, but in this question, we will be actually considering this case also. Okay, this is called as salvage. Okay, salvage, or it is also called as leftover. Okay, such names you can give it for this one. Okay, in the last question, the shopkeeper did not do anything with the leftover cakes. He just threw it away. Okay, that was a loss for him. But in some cases, what we can do is we can actually get a refund for this. Okay, for example, in you must have heard of this. Some shopkeepers, they will buy goods from the wholesaler. Okay, if it is not sold, what will he do? He can return it back to the wholesaler for a refund. Okay, he will get a refund. Okay, that situation also we are going to consider in the question. Okay, I'll read the question. For example, suppose you have this 5 cakes, you can give it to the this at the end of the day, 5 cakes are left over. Okay, or sometimes newspapers. Okay, 25 newspapers were there in your shop. Only 20 newspapers were demanded that day. Okay, 5 newspapers were left over. Okay, this 5 newspapers you can sell it the next day for a lesser amount. Okay, this 25 newspapers were there. 20 only were demanded, 5 were left over. The next day also you can sell these 5 newspapers for a lesser amount. Okay, actually a newspaper cost ₹10, but in this case he can sell it for ₹5. Okay, lesser amount. Okay, this lesser amount will also add up to your profit. Okay, so we have to bring this equation also into our conditional payoff equation. Okay, we already saw the equation, no? What was our equation? Conditional payoff is equal to, what did we say? Sale quantity multiplied by the selling price minus production quantity into the cost price plus. Okay, this is actually payoff means profit, no? So he is going to sell it for ₹5 the next day. Okay, that is also going to add to his profit. Okay, rather than throwing away all these 5 newspapers, he can again sell it the next day for a reduced amount. This reduced amount will also add to his profit. Is it clear? നമ്മൾ വെറുതെ ആ 5 പത്രം എടുത്ത് ദൂരെ അറിയുന്നതിന് പകരം നമ്മൾ ഈ 5 പത്രത്തിന്റെ വില കുറച്ചിട്ട് പിറ്റേ ദിവസം നമ്മൾ വിൽക്കുന്നു. That will also add up to our profit. Okay, so what will be our profit? Again, salvage quantity. നമ്മൾ ഇവിടെ sale quantity പറഞ്ഞതുപോലെ ഇവിടെ salvage quantity എന്ന് പറഞ്ഞാൽ ലെഫ്റ്റ് ഓവർ എത്രയുണ്ടോ അത് into salvage price. Okay, salvage price ഇവിടെ ₹5 ആയിരുന്നല്ലോ. Salvage price. Okay, is it clear? Okay, so this is going to be the formula. അപ്പൊ ഇങ്ങനത്തെ കേസസിലൊക്കെ നമ്മുടെ ഫോർമുല ഒന്നും കൂടെ ചെറുതായിട്ടൊന്ന് എക്സ്റ്റെൻഡ് ആവും. അത്രേ ഉള്ളൂ. There is no other difference. ബാക്കിയെല്ലാം നാം പറഞ്ഞതുപോലെ തന്നെയാണ്. എത്ര എമൗണ്ട് ആണ് ലെഫ്റ്റ് ഓവർ വന്നതെന്ന് നോക്കുക. Okay, how will you calculate the left over? When the supply is greater than the demand. അപ്പോഴല്ലേ വരുന്നത് ലെഫ്റ്റ് ഓവർ. You actually the supply greater on the situation is this one, 25 where the supply is greater, only 20 were demanded. How will you get the salvage quantity? Subtract both. Okay, so when the supply is greater than the demand, supply minus demand ചെയ്താൽ we will get the salvage quantity. Okay, what about demand is greater than supply? In such case, what will be the salvage quantity? Who can tell me? When demand is greater than the supply, what will be the salvage quantity? Salvage is only leftover. When demand is greater than the supply, will there be any leftover? Will there be any leftover? Very good. When the supply is lesser than the demand, that means you have 20 newspapers. Okay, the demand came for 25 newspapers. Okay, all these 20 newspapers will be sold. Will there be any leftover? No, leftover will be 0. Okay, so when supply is lesser than the demand, our salvage quantity is going to be 0. Okay, so just read the question. A retailer purchases cherries every morning at ₹50. Okay, so this is going to be his cost price. Okay, and sells them for ₹80. This is his selling price. Any case remaining unsold at the end of the day can be disposed of next day at a salvage value of ₹20. Okay, so what is the meaning? At the end of the day, whatever is left over, what is he going to do? He will sell it the next day for how much rupees? For a reduced amount. Okay, on every natural day, ordinary day, if he is going to sell, he is going to sell it for ₹80. Okay, but the leftover, he is going to sell it the next day for ₹20. Okay, so this is also going to add to his profit. Rather than throwing all these cherries away, if he is going to sell it for a lesser amount the next day, it is also going to add to his profit. Okay, therefore they have no value. Okay, after that they are not having any value. ₹20 he is going to sell it. All the leftover cherries is going to sell it for ₹20 the next day. Okay, so this is called as the salvage value. Okay, sometimes in the question it will be given all the leftover were freely given to the nearby hospital, or he gave it for the charity. Okay, in such cases salvage won't be there. Okay, sometimes they will tell they gave it for a second, like you have second hand. Okay, all these dresses and all you will sometimes sell it for second hand. No, so all the leftover dresses they sold it for second hand for a reduced price. Okay, in that case we will have a salvage value. Okay, next one, past sales have ranged from 15 to 18. Okay, now when you hear this type of questions, immediately what should come to your mind? SON and COA values should come to your mind. Okay, so past sales have ranged from 15 to 18 means SON, what is going to be the states of nature? States of nature is going to be 15 to 18. Similarly, COA, course of action, what is it going to be? It is again going to be 15 to 18. Okay. The following is the record of sales for the past 120 days. Did you understand something else? 120 days is given. On each day, how much that value is also given. So what can you calculate? You can calculate the probability. Is it clear now? Are you getting it? Okay. The total number of days are given, and in that 12 days, this is the case. 15 cases are sold. Okay. In this 120 days, for 24 days, how many cases are sold? 16 cases are sold. Okay. So for selling 16 cases, what's the probability? It is 24 divided by 120. This is going to be the probability. In this, what is the probability? Number of days is given as 12. 12 divided by 120. Here, 48 divided by 120. Here, 36 divided by 120. These are going to be the profit values. Okay. Find how many cases the retailer should purchase per day to maximize his profit. Okay. നമ്മൾ നേരത്തെ കണ്ട ക്വസ്റ്റ്യന്റെ ഓൾമോസ്റ്റ് സെയിം ആണ് this question. Only thing is you have to add the salvage value. Okay. Actually, since there is no time to work out this problem, I'm already worked out this problem, so I'll show you that. Okay. See, the same question I've written over here. I'll just explain how to do that because we don't have time to work out the problem. Okay. So similarly, in the previous question, we took D1, D2, D3, and D4 as a demand. No, we are taking that as the states of nature. Okay, this is the daily demand. Okay, that is how many cases? 15 to 18 cases. No, so 15, 16, 17, 18 will be D1, D2, D3, and D4. Okay. Similarly, we have S1, S2, S3, and S4. That is COA. COA means the customer's options. Okay, whether he can use strategy S1 or S2 or S3 or S4. That also corresponds to 15, 16, 17, and 18. Okay, the row-wise values in our payoff matrix. Okay, so we have already decided what is going to be our demand and what is going to be the supply, or it is also called as COA, that is course of action. Okay, our formulas remains the same. Just now we saw that, no, condition payoff. For writing that matrix, we need to use a formula. Okay. Formula is sale quantity into price. We have already seen what is sale quantity. Okay, into price means this is the selling price. Okay, selling price minus purchase quantity. Purchase quantity is stock. This will be our row-wise values. On top of the matrix, we have the row-wise. You don't know, that is our actually purchase quantity into cost price. This is our cost price plus this is the salvage quantity into salvage price. Okay, leftover, how much is leftover? That is salvage quantity. If the demand is greater, then there will not be any salvage quantity. Okay, if the supply is greater, then how will you find the salvage quantity? Supply minus demand. Supply means stock itself. Stock minus demand will be our salvage quantity. Okay, into salvage price. He is going to sell it for a reduced cost of rupees 20. No, so 20 is going to be our salvage price. Okay. Sale quantity, how did you calculate? Sale quantity, whichever is lesser is going to be the sale quantity. Demand or supply, this is the clue. Okay, whichever is compare smaller, compare the smallest value. Okay, when you're considering demand and stock, the smallest value will be your sale quantity. Same thing is written over here. Okay, just you have to remember, take the smallest value of demand and supply. That will be your sale quantity. Okay, salvage quantity, when demand is lesser than the supply. Okay, demand is lesser. When demand is lesser, you will have leftover in this case. Okay, something under will be leftover. How will you calculate how much is leftover? You have to subtract how much you have stocked, subtract it with the demand. Okay, so you will understand how much is leftover. നമ്മുടെ സ്റ്റോക്കിനകത്ത് നമ്മൾ 25 cakes വെച്ചു. Demand വന്നത് 20 cakesന് മാത്രമാണ്. What is leftover? 25 minus 20. That is S minus D, which is 5. Okay, അപ്പോൾ leftover കണ്ടുപിടിക്കുന്നത് ഇങ്ങനെയാണ്. ഇനി ഡിമാൻഡ് ഗ്രേറ്റർ ആണെങ്കിൽ എന്തെങ്കിലും ലെഫ്റ്റ് ഓവർ വരുന്നുണ്ടോ? അല്ലെങ്കിൽ ഡിമാൻഡ് ഇസ് ഗ്രേറ്റർ ദാൻ ഓർ ഈക്വൽ ടു സ്റ്റോക്ക് ആണെങ്കിൽ there is no leftover, it is 0. Okay, 0 ആയിട്ടുള്ള കേസും നമ്മൾ കൺസിഡർ ചെയ്യണം കേട്ടോ. കാരണം ആ ഒരു ഭാഗം മാത്രമേ 0 ആണെങ്കിൽ what happens? Only the salvage quantity becomes 0. 0 into salvage price. This full term will become 0. പക്ഷെ അതല്ലാതെ ഈ term ഒക്കെ ഇപ്പോഴും still we have to consider this term now also. Okay, is it clear? 0 ആണെന്ന് കരുതി full ആ value തന്നെ 0 ആക്കരുത്. Only this term will become 0. Is it clear? Okay. 0 into salvage quantity, sometimes it will become 0. 0 into salvage price, only this term will become 0. You have to consider these two terms in the equation. Okay. See, this is our payoff matrix. Okay. This area is what you are calculating using the formula. Okay. How will you calculate it? D1 S1. That's E value, this value. How will you calculate? D1 S1 is equal to, this is our sale quantity. Take the minimum of these two values. Here also 15, here also 15. So it is minimum is 15 into, this is our selling price 80. Okay, minus, this is our production quantity. Production quantity means the value that will come in the row. Okay, production quantity for this cell. What is the production quantity? 15. Okay, so 15 into the cost price is 50 plus we have to take the salvage value into consideration. Okay, here it is 15, here it is 15. Is there any leftover? No. Okay, there is no leftover, so it is 0. Salvage price is 20, so we get 40. Okay, and just tell the second value also, D1 S2. How will you calculate D1 S2? D1 S2. Okay, first we have the sale quantity 15 and 16, which is the minimum value 15. Okay, so 15 into, we have the selling price 18 minus 16 is the production quantity. 15 and 16. Which one will you take as the production quantity? Always remember in the row, what is the value? That is your production quantity. Don't take these values for production quantity. These are the demand values. These are the production values. Okay, for this cell, production quantity is 16. Okay, 16 into, this is our cost price plus 16 is our production quantity, 15 is our demand. Demand is lesser, production is more. Okay, so what is the salvage? What is the leftover? 16 minus 15. What is that? 16 minus 15. Leftover is 1. Okay, so here we have 1 multiplied by 20. 20 is the salvage price. Okay, is it clear? Then again, one more we'll see. D1 S3. D1 S3. This is our cell. Okay, we have to calculate the sale quantities. For sale quantity, take the minimum of demand and supply. Here 15, here 17. What is the minimum value? 15. So here we have 15 into the selling price. Selling price is 18 minus production quantity. We have to take the values in the row. Okay, so it is 17 into cost price is 15 plus. Here we have 15, here we have 17. 17 items we have stocked in the shop, but demand was only for 15. Okay, so what is the leftover? 17 minus 15, that is 2. Okay, so here we have 2 into salvage price is 20. Okay, we have 390. Is it clear? So like this, we have to make the entire table. Okay, we have taken all these values. Then you fill out this part. Okay, once you have filled out this one, what will happen? You have to take the probability values. Probability values, you already know how to calculate now. Okay, we have on the total number of days as 120. Okay, in that 10 days, oh, how many days? Yeah, for 12 days, it was the first. Do you remember? 15 cases were sold for 12 days. Okay, 12 days. What is total number of days that is considered? It is 120. So how will you get the probability? 12 divided by 120. Okay, so here we have 12 divided by 120, that is 0.1. Similarly, all the other values also you have to calculate. Okay, then we have this one. See, I am leaving it blank because for you the calculation will be easier. You will save more time when you do it directly. Okay, but if you have a doubt whether you will make mathematical errors, in that case, you can actually solve this. Okay, how did you solve this? 450 into 0.1. Okay, that value I'll be writing over here. Similarly, 420 into 0.1, I will write over here. Okay, 390 into 0.1, I will write over here. Okay, so similarly, what happens? This entire column, you are multiplying with this entire column to get these values. Okay, similarly, the second column, you multiply with the probability values, you will get these values. Okay, add this column wise. Okay, here you will get a value, here you will get a value, here and here you will get a value. Check out which is the maximum value and that will be your highest EMV. Okay, is it clear? Here, 420 into 0.1 I will write over here. 480 into 0.2 I will write here. 480 into 0.4 I will write here. 480 into 0.3 I will write here. Okay, but see, this is taking so much of time, no? So what you can do is leave this. Okay, don't do this. Just calculate it in one go. 450 into 0.1 plus 450 into 0.2. You are actually multiplying these two columns. Okay, and then adding it. Okay, same thing തന്നെയാണ് ഇവിടെയും ചെയ്യുന്നത്. ഇവിടെ നമ്മൾ ഇൻഡിവിജ്വൽ വാല്യൂസ് എടുത്ത് എഴുതിയിട്ട് എല്ലാം കൂടെ ഒരുമിച്ച് ആഡ് ചെയ്യുന്നു മാത്രം. ഇവിടെ നമ്മൾ ഒറ്റയടിക്ക് വാല്യൂസ് എല്ലാം കൂടെ ആഡ് ചെയ്ത് മൾട്ടിപ്ലൈ ചെയ്ത് പോകും. Okay, so do this column wise. Okay, EMV values you will get. Okay, so EMV value for S1, what will be the value? 450 into 0.1 plus 450 into 0.2 plus 450 into 0.4 plus 450 into 0.3. Okay, you will get the first value here. That is EMV for S1. This strategy, using strategy S1, what is going to be your profit? Okay, similarly, for strategy S2, what is going to be your profit? That is 420 into 0.1 plus 480 into 0.2 plus 480 into 0.4 plus 480 into 0.2. Okay, similarly, you do that. What will be your value? These are going to be your values: 450, 486, 474 and 474. Okay, in this, which is the maximum value? Maximum value is 486. That is for S3. Okay, S3 means what? S3 means you have written 17 here, no? So 17 cherry boxes you have to buy in your shop so that you can minimize the loss and maximize the profit. Okay, so highest EMV 486 corresponds to S3. That is, retailer should purchase 17 cases in a day. Okay, is it clear? And this is how you have to solve all this type of problems.